Hello everybody, we are going to talk about the UDP protocol today, or actually UDP stands for User Datagram Protocol. Not sure what it actually means, but yeah, so this is what it stands for. And basically, this is one of the protocols that work with the Internet Protocol in transmitting data between different devices on the internet. If you remember, the Internet Protocol is responsible for actually like routing around from one device to another. But this protocol, UDP, it works with the Internet Protocol to like transport data. And there's also another protocol called TCP, and this one's arguably more reliable than UDP, but today we're going to be talking about UDP. So basically, in the UDP header, it consists of a few fields. So firstly is the length of the data that it's transporting. And this field has 16 bits. So this field can only be 16 bits long, and this represents the length of the data. So at most, we could have 1, 1, 1, 1, 1, 1, 1, all the way to 16 ones. This is like the max length of the data. And let's figure out, so how long is this? So and this is basically 2 to the power of 16 minus 1 bits long. So the data can be at most this many characters long. And say we wanted to transport a mess. So this is like the length of the data. So let's write that here. So this is the first field. And then is the actual data. So data in UDP, data is segmented into different packets for easier transport, and these packets can arrive at their destination in a different order. It doesn't really matter. It's just segmented into different parts. So for example, if we want to send the message, say hello, in UDP, we'd first have to convert this into binary somehow, so ones and zeros. So how we can do that is through ASCII or ASCII or whatever So the letter H, the ASCII code for the letter H is 104. So if we turn that into binary, hold on. So that is this number right here in binary. So 110 1000 101000. And I think that is it. This feels wrong, but still. It should be 8 bits long. So let's do this for every character. So this is H, and then E, L, L, O. So H, E, and then binary of 101 is this 1, 0. Okay. Yeah, so this string of binary represents E in our encoding. And then let's do L. Binary of 108 is this, so 0. One, 0, 0. Okay, and then let's repeat that one more time for the second L. And then let's do O. So this is tedious, but let's just see how UDP actually transports the data, or how the data is encoded anyway. let's see, 111. Okay, I think that is it. So, and then it segments this data into different parts. So the first segment could be like the first 3 letters, and then there. So let's just do 0, 1, 1, 0, 1, 0, 0, 0. And this represents the first letter, H. And then we can add the second letter or segment the second letter here. Okay, this is a bit slanted, but you get the point. And then this is the first 3 letters, and then we can do the last 2 letters. And there's one last field called the checksum. So the checksum is used to make sure that the data has not been corrupted along the way. So when we segment this into 2 rows, we're actually providing a way to, like a simple way to verify that the data has not been corrupted or is actually correct. So let's just see how that works. So first let's add the binary numbers. 0, 1, 0, 1, 1, 0. Okay. I do believe I copied. Oh no, it's right. And then 0, 1, 1, 0. Okay, so and then we'd add these 2 segments together. We can, okay, I'm not going to do that because that is taking a very long time, but you get the point. So this result will be the checksum. And how it basically verifies is UDP and IP together, they send this packet of data. So this is the actual data, and then this is the checksum. So upon receiving this packet, whoever is receiving this packet would verify that the data has not been corrupted by just testing these 2 segments out by adding them together and verifying that the checksum is what it actually is actually correct. And so a checksum, you can imagine, would be provided to whoever is receiving this data, and whoever is receiving this data would add together whatever they receive here. And if it's incorrect, they can know that something has been corrupted, and usually they just ignore the packet if it's incorrect. So yeah, so this is a basic idea of how UDP encodes data to be sent over the internet protocol. And other protocols like TCP use similar ways to encode this data. And as I said before, TCP, I believe it is a more reliable method of transporting data than UDP, but UDP is just faster. So yeah, that'll be all for today. Bye.